Today's topic is balancing a chemical equation. This is actually an important topic for grade 10 learners. We have to know how to balance a chemical equation. So here I have an example, a simple example, balancing of a simple chemical equation. You could see that hydrogen gas H2G stands for hydrogen gas react with oxygen gas O2G. The product is water molecule H2O in gaseous state. This is one of the simple equation. This equation is unbalanced. So we can easily check whether the equation is balanced or unbalanced by counting the number of atoms either side of this arrow. On the left hand side of the arrow, what you could see is a reactants. This left hand side we have the reactants, and the right hand side we have the product, or in other cases you will see products, more than one compounds or atoms or molecules you could see sometimes. So if you count the number of atoms on the left hand side, you could see that we have two hydrogens here. So I just wrote here two hydrogen. Oxygen you have two, and then the right hand side you have two hydrogens and then one oxygen. Since there are two oxygen on the left hand side and one oxygen on the right hand side, this equation is unbalanced. So you can write here the equation is unbalanced. This kind of equations, the equations which are unbalanced, we can't use in chemical equations or for calculations of atoms or molecules, or simply you could say stoichiometric calculations, quantitative analysis of chemical compounds. So we need to balance these equations. It is actually not that difficult to balance an equation. We have to learn the different methods how to balance a chemical equation. I'm trying to assist you on that matter today. So we have to know how can we check whether the equation is balanced or not. I just showed you now, but in an explanation or in the format of a definition, we have to know how to check whether the equation is balanced or not. I'm going to show you that, how to check whether the equation is balanced or not. So look at this statement. A balanced chemical equation have the same number and type of each atoms on both sides of the equation. So the both sides of the equation, I showed that in the equation, the one we were busy with, you could see that this is the equation, chemical equation. So a chemical equation has two sides. On the left hand side where you see the reactants, right hand side you see the products. Then now let's see the description. A balanced chemical equation have the same number and type of each atoms on both sides of the equation. If you have hydrogen on the left hand side, you should have hydrogen on the right hand side. You can't have carbon or aluminium since you don't have that element on the left hand side. You have oxygen here, you should have oxygen, and their number should be equal. So here you could see that the numbers are not equal, so the equation is unbalanced. So that is the statement, how to check whether the equation is balanced or not. Then an important thing when you balance a chemical equation is you have to know what is the coefficients in a chemical equation. Coefficients, they are numbers, and those numbers should be simplest whole number ratios. You can't have decimal or fraction numbers there, then your equation is wrong. So we call those numbers are coefficients, and I will show you different types of coefficients and how we substitute the coefficients. We all know conservation of mass. Conservation of mass says that the total amount of mass remains constant in a closed system or isolated system. Here, that statement is important. Mass is always conserved. Conserved means remains constant in a chemical reaction, especially if the system is a closed system. Closed system means no particles are entering to the system or no particles are going away from the system. We are going to balance this chemical equation. Before balancing the chemical equation, we have to know the different steps. Actually, there are 4 different steps. They are simple steps. Let's have a look at the different steps of balancing a chemical equation. You can call it as easy steps for balancing a chemical equation. Let's see which are the different steps. The first one is, when you balance a chemical equation, the first step is, look at the first step. Write the unbalanced equation to show the reactants and the product, like this. You should write the unbalanced equation. If the equation says that, like in words, hydrogen plus oxygen gives water, then you should be able to write them as in the form of an equation, chemical equation. You should know H2 stands for hydrogen, O2 stands for oxygen, and H2O stands for a water molecule. You should know that. Otherwise, you will be unable to solve the question. So the first step is write the unbalanced equation to show the reactants and the products. The second step is write down how many atoms of each elements they are on each side of the reaction arrow. You must write down each elements on the left hand side and the right hand side, like this. Here you have 2 hydrogens, 2 oxygen. Here on the right hand side you have 2 hydrogen and 1 oxygen. So you should write down how many elements are there. That is the second step. The third step is, look at the third step. Add coefficients. Add coefficients. Coefficients means the numbers in front of the formula. So the numbers of atoms of each element is the same on both sides of the equation. So the coefficients comes here. You should see number 1 is there. It is hidden there. If you just see H2, that means it is 1 H2. This is 1 O2, 1 H2O. So that numbers, after you implement or you use that number, those number of elements should become equal. So you should change those coefficients here until you get equal number of elements on the either side of the arrow. That is number 3 explains. Then the fourth and the last one is, look at here. Indicate the states of matter of the reactants and product and check your work. So there are 3 states of matter for a grade 10 to 12 child. The first one is solid, liquid and gases. Those are the 3 states of matter. Let me write here. The first one is solid. We use letter S for solid. And the second one is liquid. We use L for liquid. And the third one is gas. G stands for gas. And if you have solutions, we use the letter AQ or AQ like this for aqueous solutions. So AQ stands for solutions. An example of a solution is you take some salt and dissolve in water. That is, salt is solid, water is liquid state. In liquid state you will get salt solution. There is no need to write salt solution. If you write salt AQ, that stands for solution. If you see AQ under a substance, it describes the state in liquid state, but that is a solution. Let's balance this chemical equation. We are going to balance the chemical equation. I'm gonna write our unbalanced equation here, then we will work from there. The unbalanced equation is hydrogen plus oxygen gives H2O. I have a hydrogen molecule, like you see, this is the shape of a hydrogen molecule. I just made a model, look like a dumbbell. Can you see that? This is the hydrogen, that one there. So you can see one hydrogen here, the other one here, hydrogen. So this hydrogen is like this if it is H2. And your oxygen is like this. Oxygen is a little bit larger molecule than hydrogen. We have two oxygen here. You see one oxygen and the other one is here, right? These are the oxygen, and you should get the water molecule like this. This is a product of the water molecule. So let me remove the hydrogen and oxygen, then the water molecule, the one here, it should be like this. I just want you to understand it better. That's why I came up with a model, so it will assist you to understand it better. So these are the models. So this is your H2O. It look like this, one oxygen and two hydrogens, and this is your oxygen, and this is the hydrogen. You see, hydrogen. So before the reaction starts, what happens? Before the reaction start, what happened? The atoms, the molecule, they should split into their atoms, like a breaking of bond. In chemistry we say that this is breaking of bonds. You see. Then this oxygen also. This is a covalent bond that bonds this two oxygen together. So these are the covalent bonds. So all the bonds are broken now. You see, they became individual atoms. It is rolling because it's not a heavy object. I made this out of the thermocol balls. You can see two hydrogen and oxygen. So they must collide in such a way that an H2O forms. You can see that an H2O is there. This is the H2O molecule. The reason the equation is not balanced, you can see that there is something missing in this equation. Oxygen left alone here. For oxygen to make a water molecule, you need two more hydrogen in this equation. You can see that you need two more hydrogen here. Now if I put the hydrogen here around it, you can see another water molecule. This is another water molecule. So you can see two water molecules. So these two water molecules should be the product of our equation. So then look at this equation, chemical equation you have here. You have only one water molecule. If you put the coefficient 2 there to make it 2, let's see what happens, whether our equation become balanced or not. I just put a 2 here. Let's check what happens. So I just remove this and let's check whether our equation could be balanced or not. So now I'm writing how many hydrogens you have here. So you already seen that in our chemical equation, or when I show you the structure of H2O. Let me use a toothpick to, otherwise it will roll away from us, you know. So you look at these are the water molecules. We got 2 water molecules. You can see clearly. So let's count the hydrogen. 1, 2, 3, 4. 4 hydrogen atoms you have there. Okay, then here let's count how many hydrogen atoms we have. Look at here. This 2 belongs to, like, you know, the equation in mathematics that, let me write that in mathematical form. Look at that. If you use this bracket, it will be more clear that this 2 belongs to both of them. So 2 times 2, your hydrogen will be 4. And you have seen in our demonstration that, look at here, in this water molecule you have 2 hydrogen, the other water molecule you have 2 hydrogen. So you have 4 hydrogens here. Let me put them together. You can see that we have 4 hydrogens here. Yeah. Hydrogen is then 2 times 2, our oxygen is 2. So we have 2 oxygen and 4 hydrogen. So let's look at the left hand side. Here we have 2 hydrogen and 2 oxygen. So equation is still unbalanced. It is not balanced. So what we can do, if you put a 2 here, like on the left hand side of H, you just put a 2 here, you can see that 2 times 2, your hydrogen becomes 4 now, and this equation is balanced now. Look at, you have 4 hydrogen on the left hand side, 4 hydrogens on the right hand side, 2 oxygen on the left hand side and 2 oxygen on the right hand side. Equation is balanced now. This equation is balanced. So let's rewrite this equation. 2 hydrogen is a gas, plus O2, oxygen is a gas, gives 2 H2O, that's a gas. Equation is balanced. Once your equation is balanced, you should write that in bracket, that equation is balanced. This is the simple way to balance a chemical equation. And I hope all of you understand this, and this demonstration with the thermocol balls, I think it make it easy. So let me show you a balanced equation like using the thermocol ball. Let me try to show you that. Look at this. These are your hydrogens. Let me take a toothpick. These are your hydrogen. Your hydrogens are here. Oxygen is here. And look at your water molecule. One water molecule and the other water molecule. You see? So you have 2 water molecules here. You can see that as a product. 1, 2, 2 hydrogens. We need to put so your reactants are 1, 2, 3, 4 hydrogens. Here you have 4 hydrogens. 2 oxygen, then your products are 1 water molecule, then another water molecule. So look at let's count the hydrogen atoms. 1, 2, 3, 4. Right hand side, 1, 2, 3, 4. Oxygen 1, 2. Oxygen 1, 2. The equation is balanced. This is how you balance the chemical equation. Thank you.